So when you are given parallel lines in a triangle, so kind of like this line and this line, it almost looks like your mid-segment, but it's not necessarily in the middle. See how this one's kind of really high? So you don't know it's a mid-segment, you just know that the two lines are parallel. So if you know that DE, your first set, is parallel to AC, then what you know is each little side chunk, so like I'll label them 1, 2, 3, and 4. Those little chunks are proportional to each other. So BD, basically number 2, over top of AD, so the bottom, so like 1 and 2, those are proportional to the other side. It doesn't mean they're equal, just proportional. So BE and EC. Oops. It's kind of hard to read. Better handwriting. Let's try that again. So not equal, just proportional to each other. So keep your left side together and keep your right side together. So then the converse of the proportionality theorem says if you know that those pieces are proportional, so the same set that we had before, then you can conclude that your two lines are parallel. So it works both ways. So for number 1, I see the parallel line markings. I don't know that they're, well, actually I do know that it's not a mid-segment because one's 14 and one's 12. If it was a mid-segment, they'd both be 14 or they'd both be 12, right? So if I want to solve for x, I know that these sides are proportional. So I can set up, it doesn't matter if I do 15 over 12 or 12 over 14. So you're just going to put your one side together on a fraction. So 14 over 12. But however you set up your first fraction, you're going to do your second fraction to match. So since I did 14, I want to do that same chunk on the other side on top over 15. Does that make sense? So I kind of did the top line, but I did the first chunk, second chunk. So whenever I did the bottom line, I did first chunk, second chunk. And now, you guys know how to solve proportions. Go ahead and solve for x, but we cross multiply. So 12x equals whatever 14 times 15 comes out to be. Go ahead and solve that on your own. I'll let you guys do a lot of the solving today. You do get a decimal, and that's okay. Don't freak out. Jake, what'd you get?
17.5.
17.5. Do we agree with Jake?
Yep. Yeah.
Yes? Okay, good. Okay, let's jump down to number 3. Number 3, I see the parallel lines. So I want to set up my proportion, but what am I missing here?
A side.
What was that, Riley?
A side.
One of the side, like, little chunks, right? So I have the x and the 36, and I have the 45, but I have the entire length. I only want to know this missing chunk. So it's kind of different than what we've been doing all the other days, because all the other days we needed the whole side. This time I don't. I just want piece and piece. So if the whole length is 55, and the big chunk is 45, what's the small chunk? 10. So who can set up a proportion for me that's going to allow me to solve for x? Ella, what would you do?
X over 36 equals 10 over 45.
Okay. Did you have to set it up the exact same way that Ella did? No. You could have done the 36 on top and the x on bottom, but if you did that, then you would want the 45 on top and the 10 on bottom. But as long as you set it up either of those two ways, you are good. So when you cross multiply, if you have 45x equals 10 times 36, you are correct. So go ahead and continue to solve that. Find x on your own. Bailey, what did you get for x?
8.
8? Do we agree?
Yes.
Okay. All right. Let's jump down to, let's do 6. All right, number 6. I see my parallel lines. I know my sides are proportional. Eliza, can you set up my proportion for me for number 6?
So you would do x over 27.
Number 6.
Oh, sorry. 3x plus 1 over 21.
Okay.
And then 4x over,
Just pieces. Don't add them together.
don't I'm just gonna x over 1 over 6.
Okay. I think this will still work. So normally we do one side together and the other side together, but I think we're okay. I think this will still be fine. We'll roll with it. Go ahead and cross multiply. But when you cross multiply with a quantity, what do you have to do with your quantities? What? Distribute, because what are you putting around them? Parentheses. So 6 times 3x plus 1 equals 21 times x minus 1. Are you guys done already? What did you get? 9? Okay, so when Eliza set hers up, she did basically across from each other, which as long as you're like, because this is the top part and this is the bottom part, as long as when she matches them up, since she did the top part, but she did like the right side then the left side, when she goes to do her next side, she wants to do the right side then the left side, it's still matched up. So over here in the red and the green, I did it how we did it on the previous examples where we did one side and the other side. So if I did the left side first, 21 and 6, and then the other side, 3x and regular x, when I cross multiply, I still put my 3x to the 6. Same with Eliza's when she did her 3x to the 6. When I flip-flop it the same way, 6 and 21, x minus 1 and 3x plus 1, when I cross multiply, I still put the 3x with the 6. So any of those proportions still end up being okay. You could even take Eliza's and flip-flop them upside down and they would still work. So there's many ways. There's 4 ways you could set them up and still get the correct answer. The key is just keeping your orders the same on both sides. Does that make sense? Okay. All right, let's move on to this section right here. Determine if MN is parallel to JL. So I have my little chunks, I have my little segments, but I want to know, are these things actually parallel or not? So what am I going to do here?
Set it up the same way and then reduce them to equal each other.
Okay, so you want to set them up, but you want to set your sides up equal to each other. And like Corinne said, if they reduce to be the same, then they're proportional. It's kind of like when we did our side thing yesterday. Set up your set up your fractions, and if they reduce, you're good. So 11 over 15.4, that should be the same scale factor as 10 over 14. Try to keep those the same. So type that into your calculator, 11 over 15.4, see what that reduces to. What do we get? 5/7. And if I do 10 over 14, you can probably do that one in your head. Does that reduce to 5/7? Yes. So if they both reduce to the same thing, are those two lines parallel? Yes, because if they're proportional, then they're parallel. So do 8 and 9 on your own. Just stick with the same side to the same side. All right, 4, 8. If I did 15 over 4 and 18 over 5, were those two things proportional to each other? Yes or no? No. Okay, so these are not parallel to each other. For 9, you had to do maybe a little bit of work here. So I had 24 and the entire length is 54. So then what is just the small chunk that I needed? 30. So depending on how you set it up, if I do 30 over 24, you could have done 24 over 30. It doesn't matter as long as you set up your second fraction in the same order. So the way I did my first, I'd have to put 37.5 on top and 30 on bottom. What do those reduce to?
5/4.
Do they both reduce to 5/4? So are they parallel? Yes. Okay. Does that make sense?
Can I just like cross multiply it and see if like they're both the same answer? I just cross multiply it because I got 900 and 900 like. And I did that to my other one and they were the same answers.
Like you multiplied 15 times 5 and 18 times 4?
Yeah.
Or like 30 times 30 and 24 times 37.5?
Yeah.
And you just got the same answer?
Yeah, and I did that to 7 too and got the same answer too.
I think basically what you did is since this side is proportional to this side, you kind of like cheated and mix matched them. So since, I guess kind of, Carly, it's just weird.
I don't think it's weird. I think it's
We taught that
easier.
You can, well, because you guys are just thinking proportions always need to be cross multiplied. That's why.
Well, I just hate typing a fraction in my computer.
So what you did is since these did happen to be proportional, then yes, since like this is proportional to this side and this is proportional to this side, then what happened was when you mix match them, you basically multiplied two different products together. And so yeah, you got the same answer because they were proportional. So I guess if you want to, that's fine. It's just weird.
Okay.
Okay? All right. So for this parallel line section, we're still kind of dealing with the chunks. The chunks are going to be proportional if your lines are parallel. Okay? So it's the same idea. It's just not a triangle anymore. It's just two regular lines with three parallel lines going in between. So parallel, parallel, parallel. As soon as you see all the lines are parallel, then you know all of these little chunks right here are going to be proportional to the chunks on the other side. Okay? So if, let's get our little definition here. If AB is parallel to CD, which is parallel to EF, all of those things, all the lines are parallel, then you know that the chunks are going to be proportional to each other. Now, I didn't do the top one because they go on forever. They don't end since there's nothing cutting them off. So you would just have AC over CE is proportional to DB or BD over DF. Okay, so for number 10, are my lines, 3 lines parallel to each other?
Yes.
So are all the chunks going to be proportional to each other? So if I want to find a missing piece for X, I know, now remember there's multiple ways to set them up. I do same side, but you could technically do the 45 and 52 and the 18 and the X. As long as you set them up, however you do the one side is the same on how you do the other. So I'm going to do, it doesn't matter if you do 45 and 18, 18, 45, I'm going to go 18, 45. So that means to match my other side, how do I need to set up the other side to make it correspond with the first way?
52. Or X is 52.
Right, because I put the 18 on top, right? Okay, so other ways you could have done it, you could have done the 45 on top, which would put the 52 on top, or you could have done 45 to 52 and 18 to X, which means you could have done the same one just flipped upside down. So 4 ways to get the same proportion, just as long as you set up the first one, the second one has to match. All right? What did you get for X after you cross multiplied here?
20.8.
20.8. Does anybody agree with Ella? Good. Okay. Let's jump down to the X's. I don't think it really matters here. Do you want to do 14 or 15? Doesn't make me any difference. 14? Okay. Raise your hand if you can set this one up for me. Sarah?
24 over 18 and 3x plus 1 over 12.
Good. When I have a quantity, which means plus or minus, what do I need to put around the 3x plus 1? Okay, and then you're going to distribute. So 18 times 3x plus 1 equals 24 times 12. Go ahead and finish solving that on your own. Aiden, you got an answer?
It's a long decimal, so I'm assuming no.
I don't have a decimal. I mean, we did get decimals today, so I'm not saying it can't be done, but this one particularly is not a decimal, so no, try again. When we distribute, what did we get when we distributed? What's 18 times 3?
54.
What's 24 times 12? 288. Is that our conclusion for that one? Okay, so when I subtract the 18, 54x gives me, there's your 270, Carly.
Yeah.
And then when I divide by 54, what should I have? 5. So, X equals 5. It didn't ask me to plug or chug or anything like that. Just find X. Okay. Do we have any questions on that one? Are we sure? Do we need to do 15? All right. That was it for today.